In the United States, social outcomes like health, wealth, and education can vary widely between race, gender, and other social groups. So you'll see a lot of charts like these, comparing average outcomes between different groups. You'll see them from government agencies, on news sites, and even from advocacy groups. These charts are well-intentioned and straightforward and accurate, but the way that they're framed can lead to toxic conclusions and reinforce harmful stereotypes about the people being visualized. This is a framing effect related to deficit thinking, and that's what we'll unpack today. But first, a quick overview of the questions we'll try to answer. 1. What is deficit thinking? How does it work? Why is it bad? 2. How can we measure it in an experiment? 3. How common is it? How big of a problem is this? 4. How is this effect influenced by the way that we design charts and graphs? And 5. Given that this framing effect exists and that it's problematic, what can we do about it? Starting at the top, what is deficit framing? Let's take a second to think about the chart on the left. This shows average hourly wages for 4 different groups of restaurant workers. You can see that, for example, Group A earns about $7 an hour more than Group B. But why is that? Why do you think Group A earns more than Group B? A lot of people explain these differences in terms of personal attributions about the people within the groups. For example, you might say Group A earns more because they're harder working, they have better customer service, or they smile more. But in reality, these differences are probably more reflective of external factors like how nice is the restaurant, how busy is it, how wealthy are the customers, how wealthy is the neighborhood. Deficit framing is presenting group outcomes in a way that encourages these personal attributions. The emphasis on between-group differences encourages blaming people personally. And this is a problem because, as we'll see, it's a very short jump from blame to stereotyping. We'll walk through an example in more detail. But first, I want to give a quick shout out to Peter Blakely, who first connected the dots between chart design and deficit thinking. She opened my eyes to this possibility that designs can be perfectly clear and accurate and comprehensible, but still potentially harmful. So let's walk through this step by step. This is the same chart, but we're changing the colors to emphasize a purple Group A versus a blue Group B. You might look at a chart like this, and your first read is average outcomes for purple Group A are better than average outcomes for blue Group B. And that's accurate, that's fine. But a lot of readers will go further and explain the differences in terms of personal attributions. So the takeaway becomes A has better outcomes than B because the people in Group A are somehow better than the people in Group B in some way that would produce these outcomes. And there's obviously nothing in the chart supporting a causal conclusion like that. Then the real damage. If you believe that the outcome differences are because Group A is better than Group B, you implicitly believe that Group A is better than Group B, and that's stereotyping. Even though charts like these only show differences in outcomes, they can be misread as evidence for intrinsic differences between people. Because so many social disparities favor majority groups, there are a lot of charts out in the wild that can be misread as evidence for harmful stereotypes about the people being visualized, particularly when they represent minoritized communities. How do we measure an effect like deficit framing? We gave people on Mechanical Turk different variations of charts showing social outcome disparities, then asked them to rate their agreement with different explanations for what causes the disparities. Then we had 10 questions, like the bottom right. As a baseline, half of these questions were external attributions, like outcome differences are because Group A works in a nicer restaurant than Group B. The other half of the questions were personal attributions, like these outcome differences are because Group A works harder than Group B. Agreement with these personal attribution questions was the main measure that we're interested in, because, like we said before, believing that outcomes are different because people are different implies belief in a harmful stereotype about the people in the groups. The first question we implicitly need to answer is, given any chart, do people jump to these personal attributions that imply stereotyping? And the answer seems to be yes. Across all conditions in our last 3 experiments, 53% of participants attributed the outcome differences to the personal characteristics of the people being visualized. So just over half of participants showed this deficit framing effect, which confirms that charts showing social outcome disparities can be misread in toxic ways that support stereotypes. The next question is, why do we think this happens? What role does chart design play in this? To understand how a chart might nudge someone towards stereotyping, first let's look at stereotypes in general. For example, let's consider a stereotype that people in the purple group are especially high earners. Stereotypes assume that within a group, people are more similar than they really are, and between groups, people are more different than they really are. The stereotype implies a distribution like this, where not only do people in the purple group earn more, their earnings are very similar, and therefore all purple people earn more than all other people. But in reality, even if average earnings for people in the purple group are higher than average earnings for everyone else, the distributions will still look something like the chart on the left. You can see that the earnings are widely distributed within groups, and between groups, there's a lot of overlap. The next question is, could certain charts create similar misperceptions? Let's walk through another example, this time looking at earnings for 4 different groups. Again, the distribution is close to reality for income between something like racial groups. You can see there are a lot more differences within groups than there are between groups. If we take these distributions and plot them as a bar chart of average income for each group, we'd end up with something like this. But when people see the bar chart, they may not imagine the distribution on the left. They may imagine something more like this. Without any indication of variability, it's easy to assume that it's not there. And just like with stereotypes, charts like these can create a false impression that people within groups are more similar than they really are, and that people between groups are more different than they really are. On the other hand, if we show the same distribution as a jitter plot or any other chart that shows the range of outcomes within groups, it becomes very apparent that within groups there's a lot of variation, and between groups there's a lot of overlap. Our basic hunch was that charts that emphasize within group variability, like the jitter plot on the left, help readers see that outcomes are very different within groups and overlap heavily between groups, and this would reduce stereotyping. On the other hand, bar charts, or any other chart that hides outcome variability, would increase stereotyping. We tested 6 different chart types, showing 4 different topics of social outcome disparities. The chart types varied their emphasis on variability. Across 3 different experiments, we consistently found that the charts that emphasize variability, shown here in blue, reduce stereotyping relative to charts that hide variability, shown here in orange. In experiment 1, we compared jitter plots to bar charts for a dataset about restaurant worker pay. In this case, jitter plots reduced personal attributions relative to bar charts by 7 points on the 100-point agreement scale. For comparison, chart type did not have a significant effect on external attributions. This supports the hunch that showing variability would reduce stereotyping. But jitter plots and bar charts are obviously not an apples-to-apples comparison, and so the next experiments tried to isolate the effect. In experiment 2, we compared 3 different charts, a prediction interval, another jitter plot, and a plain dot plot. In this experiment, the dot plot replaced the bar chart from experiment 1. The dot plot has no indication of within-group variability, but unlike a bar chart, it's symmetric and uses a dot as the marker. Then, in addition to jitter plots, we also tested prediction intervals. Because they're based on standard deviation of the outcomes, the intervals are long and tend to overlap. But unlike jitter plots, prediction intervals don't show the shape of the distribution or use individual markers that could be imagined as small anthropomorphic dot people. We also varied topic. Instead of just looking at restaurant worker pay, the chart could also be about either household income, literacy scores, or life expectancy. For this experiment, we found that prediction intervals reduced personal attributions compared to dot plots by 7 points on that 100-point scale. Jitter plots landed in the middle, closer to prediction intervals, but not significantly different from either of the 2 other chart types. Again, in experiment 2, the chart showing overlapping ranges of outcomes reduced stereotyping relative to the chart hiding it. In experiment 3, we wanted to see if just showing any kind of uncertainty was enough to influence personal attributions, or if seeing overlapping ranges was the driver of the effect. So we tested confidence intervals based on standard error around the group mean, which would show shorter bars with little overlap, versus prediction intervals based on standard deviation of the outcomes, which would show as long overlapping bars for the same data. We found that prediction intervals reduced personal attributions by 5 points relative to confidence intervals. This suggests that just seeing uncertainty isn't enough to impact stereotyping. Instead, it's about seeing variability and the overlapping outcome ranges. In all 3 of these experiments, the chart type showing long, overlapping ranges reduced stereotyping relative to the charts that hide within group variability and emphasize between group differences in outcomes. Given that charts can be misread as evidence supporting stereotypes, and that the way they're designed can make this better or worse, As designers, what should we do differently? Social outcomes are messy, especially in the context of big, complex issues like inequality or systemic racism. It can be tempting to try to reduce data into simple averages or easy sound bites, like Group X earns more than Group Y. But not only does this rob readers of important context, it can also make disparities worse by misleading audiences towards harmful stereotypes. Rather than chase false simplicity, our designs should lean into the messy truth. The charts on the left are overly simplistic. When presenting social outcomes, bar charts, dot plots, and confidence intervals hide within-group variability and lead viewers to harmful conclusions about the people being visualized. We should do less of these. On the other hand, the jitter plot and prediction intervals on the right show within-group variability and make it easy to see how much outcomes actually overlap between groups. This reduces tendencies to blame the differences on the people within the groups and makes it harder to misread charts as evidence for harmful stereotypes. When visualizing social outcome disparities, especially involving people from minoritized communities, we want to do fewer charts like these on the left and more charts like these on the right.